Our chemistry with Pastor Dan. We've been talking about placement of electrons. We did electron configurations the last 2 days, talking about placement of every electron by energy level and orbital and how many are in there. Now we're going to do something called quantum numbers. Now, quantum numbers is a faster way of doing electron configuration, but it requires you to think a little more. So what we're going to do is we're going to convert all of that information we've talked about, 1s2, 2s2, 2p6, 3s2, 3p6, all that process, and make it into 4 numbers. So it means to convert electron configuration into 4 numbers. It's quicker, but it does take more thought process. So these are the different orbitals of this. This is how S exists. There's only one suborbital for the S orbitals. There are 3 options, and here they're all together. 3 options for P. D has 5. These are 5 different options. And there are 7 for F, but there's a couple more that popped up here, and I think that has to do with mutations and hybridizations. So how do we do this? It's a way to convert into 4 numbers, and those numbers are identified as energy levels, orbitals, suborbitals. We talked about those different arrangements there, and spin. Now, we do spin to overcome electron repulsion. What does that mean? If I have one electron, I have a second electron, and bring them close together, they're going to want to fly apart because like charges repel. Now, the way an electron overcomes this is it spins, either in the positive vector or the negative vector. If they're spinning in opposite directions and they come close to each other, they can coexist, but they can only have 2 electrons spinning because there's only 2 options. This and this and this and all this other stuff is the same idea. All right, so when we do this, we need a number here, and S, P, D, and F are letters, not numbers. So whenever we talk about L, if it's S, it's 0. If it's P, it's 1. If it's D, it's 2. F is 3. Now, how about the number of suborbitals? Remember I talked to you, there's 1, 3, 5. So we said that S has 1 suborbital. So what we do is we put down a line to represent it. And we take the negative of L to positive L. Negative of 0 is 0, and put the electrons in. All right, so we said that P had 3 suborbitals, and we go 3 dots from negative 1 to positive 1. Those identify the suborbitals. 5 exists for D, so we get negative 2 to positive 2, and 7 exists for F. Now, the best way that I always think of this is like a hotel. All right, when you check in the hotel, the first thing you go to is the floor. Well, floor is like the energy level. Okay, where are we at? Then you go to the wing. Well, orbital, SPD, those are the wings. And then you go into the rooms. That's where we get this 1, 3, 5, and 7. So like the S orbitals is the penthouse, the top. There's only 1 room up there. 3 is like the elite room. There's only 3 rooms. 5, and you get down here at 7. We're pretty filled up. All right, so let's take an example. Let's do arsenic. Now, when we do this, we're going to take the last configuration, all the configuration. Arsenic, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. The last configuration for arsenic is 4p3. That's one that's unique for arsenic. Okay, so what's the energy level there? Energy level is 4. Now, we said P, remember, S is 0, P is 1, D is 2, F is 3, so therefore it's 1. Now, how many suborbitals do we say there were? How many rooms in that suite there were? There are 3. We go from negative 1 to positive 1, and we're going to check in 3 electrons. Okay, so like this is a convention town. First guy comes in, we check him in the negative 1 room. Second guy comes in, checks in the 0 room. Third guy comes in, he checks into the first room, the 1 room. So what room is that last electron in? That last electron is in 1. Now, is it in a positive spin or negative spin? Is it the first one in or the second one in? Well, we have 1 in there, so it's going to be plus 1/2. So we identify the spin as either plus 1/2 or negative 1/2, and we have to write the plus because that identifies the vector. If you don't have the plus there, it's wrong. All right, let's do another one. Let's do silver. Silver, 4d9. Okay, so the N is going to be 4 because it's 2, it's L, L is D, so it's going to be 2. Now, how many suborbitals did they say that D had? D had 5 suborbitals. Now, how do we know that? We take our periodic chart. Remember, the D's are in the middle here, and there are 10 inside of there. we've got 2 suborbitals, 2 spinning options. So 10 divided by 2, that's how we get the 5. All right, so we have from -2 to +2. We're checking in 9 electrons. So the first guy checks in, second guy checks in, third guy checks in, fourth guy checks in, fifth guy checks. When the sixth guy checks in, the manager realizes we're out of space, so he's going to make the guy check in. But when he checks in, he's going to have to sit on his head. Never happened about it. 6, 7, 8, 9. Last electron is in there at 1. Now, he's sitting on his head. He's the second electron in. He's spinning the negative vector. That's -1/2. All right. So arsenic, for potassium rather, 4s1. Go through that. Try that. 4, 0. Now, S is always easy because if you have L, there's only one option. Only one option. One electron checks in. It's going to be 0, and it's +1/2. All right. Let's try the last one. There we go. Okay. Now, we can also go backwards. What do we mean go backwards? Well, if I give you the N, L, M sub L, and M sub S, we can identify what the element is. So because it's N is 5, the energy level is 5. Because it's 2, the orbital is D. Now, remember there are 5 wings, 5 rooms, 5 suborbitals there. We're going to have the last electron in -2. So it's either going to be 1 or it's going to be 6. Well, because it's +1/2, it's 1, so it's 5d1. If you look at the periodic chart, 6s2, 5d1, it's lanthanum. That's my answer. All right, so I've got 1, 2, 3, 4 problems for you to do. I want you to give me the quantum numbers for aluminum, tungsten, berkelium, and then tell me what element would be 5. N is 5, L is 0, M sub L is 0, M sub S is -1/2. Pause this, work it through, and then we'll go over the answer. Okay, here we go. So we have 3p1, so it's going to be 3, 1, -1, +1/2. Tungsten is 5p4, so it's 5, 2, 1, +1/2. And then berkelium is 5f8, so it's going to be 5, 3, -3, -1/2. For 5, 0, 0, -1/2, that's 5s2, which is strontium. Hopefully that wasn't too bad. Take care. Be good. God bless. Bye.